We've seen that the derivative of sine is equal to cosine. Now let's take a look and get an idea of what the derivative of cosine might be. If we look at the graph of cosine, remember that cosine of 0 is 1, and then we hit 0 at pi halves, negative 1 at pi, 0 at 3 pi over 2, etc. I'm just going to sketch this graph really quickly. We've got something that looks like this. This is cosine. All right, this is y equals cosine of x. Now, if we want to look at the derivative, we can see that we've got horizontal tangent lines at 0, at pi, at 2 pi. Basically, all of the multiples of pi, we're going to have horizontal tangent lines, which means the derivative will be 0. Now, if we look at the interval from 0 to pi, the function is decreasing. That means that the derivative is going to be negative, and so it's going to look maybe something like this. And then on the next interval, the function's increasing, so the derivative is positive. All right, I'm going to finish drawing this, but take a look at it and see if you can have an idea of what it might be equal to. If we take the derivative of cosine of x, we don't quite get sine, because sine starts at 0 and then moves upward. We actually end up with negative sine of x. At least that's what it looks like. You could do a very similar calculation with the limit definition of the derivative, looking at cosine as a sum, evaluating some limits, etc. But I don't want to take the time to do that because we just did something similar with sine. If you want to, if you're a more adventurous student, then I would recommend giving that a try, seeing if you can work that out on your own. But for now, I'm just going to leave that as an exercise for you to do. But we've got our derivative of sine, we've got cosine now. I want to figure out the derivative of tangent, and then I will just give you the rest of all of them. So let's figure out d over dx of tangent of x. Now, we're not going to look at the graph. This one ends up being a little bit more complicated, and it's not quite so clear from the graph what it's going to look like. But we do have a tool that we can use. We know that tangent is the same as sine over cosine. So we can rewrite tangent of x as sine of x over cosine of x. And then we can use the quotient rule because this is a derivative of a quotient. Remember, when we take the derivative of a quotient, it starts off low d high minus high d low. So we take the lower function, which is cosine of x, times the derivative of the higher function. We saw the derivative of sine is cosine, so that's going to be times cosine, minus, that was low d high, now we've got high d low. Our high function is sine of x times d low. The derivative of the lower function, the derivative of cosine, is going to be negative sine of x. We just saw that. All over low squared. So that's going to be all over cosine squared of x. Now, if we look at the numerator, cosine of x times cosine of x is cosine squared of x. And then in the second term, we've got two negatives, and those are going to cancel to give us a positive. Sine of x times sine of x is sine squared of x. This is all over cosine squared of x. And if we look at the numerator, there is a trigonometric identity here. Sine squared plus cosine squared equals 1. So this is just going to be 1 over cosine squared of x. And that is the same as secant squared of x. So the derivative of the tangent function is secant squared. And once we have these three, we can figure out the derivatives of cotangent, secant, and cosecant, because these are all things that are quotients involving sines, cosines, and ones. But I'm not going to go and do all of those out now. You can figure those out if you would like. For now, I'm just going to give you a table with the derivatives of the 6 trigonometric functions. Boom! We have the derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of tangent is secant squared. Those are the ones that we've already seen for ourselves. But also the derivative of cotangent is negative cosecant squared, the derivative of secant is secant tangent, and the derivative of cosecant is negative cosecant cotangent. These are really important to know, because once we know these and we've got the product rule and the quotient rule, we can do all sorts of derivatives involving trigonometric functions, which is exactly what you'll get to do in some of the practice problems.